So far we have solved quadratic equations using square roots and by graphing. It is now time for a new method. At the end of this lesson you'll be able to solve a quadratic equation by factoring. Alright, hopefully you're getting really good at factoring now because we've been practicing it a lot. There is a connection between factoring and solving, so we are going to discover that right now. If you were to factor the expression x squared plus 2x minus 24, remember we take the 1 times the negative 24, we're going to get x. We're going to be looking at what times what would give me negative 24, negative 6 times 4, negative 4 times 6, negative 12 times 2. I do notice we wanted to get a positive 2, a negative 4, and a positive 6 will do it. So minus 4 plus 6. So that is factored. Okay. If you were to graph this now, and we want to know the x-intercepts, so we would get, this is what it would look like graphed. Okay, what are the x-intercepts? The x-intercepts are 4 and negative 6. All right, hopefully you remember the connection that we have been making, that notice that if I had x minus 4, we had an x-intercept of 4, and when we had x plus 6, we had an x-intercept of negative 6. All right, this next one, if we wanted to factor the expression x squared minus 16, since you can take the square root of the 16, this is going to factor as x plus 4 times x minus 4. The intercepts, again, if I were to graph this, this is what the graph looks like. The x-intercepts are going to be x equals 4 and x equals negative 4. Please notice again that they just end up being the opposite of what I had inside of the parentheses. All right, the next one, if I had consider the quadratic expression x squared plus 5x, and I ask you to factor that, this would be a GCF problem. So they both have an x. If I came over here and divided both parts by x, this first part would be x, the second part would be 5, and then the x-intercepts, if we were to graph this, that's what my graph is going to look like. So it touches the x-axis at 0 and at x equals negative 5. All right, so notice again we had the opposites. All right, and then the last one, if I were to factor this expression, let's see here. Well, I'm not going to put it in the blank quite yet. We need to put 2x, divide by 2. We're going to do 2 times negative 3. That gives me negative 6. Negative 3 times 2. Negative 2 times 3, negative 6 times 1, negative 1 times 6. I want to get a positive 5. That last one works. And we have to divide the second one by 2, so I'm going to get 2x minus 1. And then we're going to get x plus 3. So this one, if I were to graph it, so I'm going to graph this expression. When I graphed it, it looked, this was one, it looks like it hits about right there. And then it hits over at negative 3. So it looks something like that. So when I asked for the x-intercepts, it hits at negative 3, which you notice was the opposite. And then this one, it actually hits at 1/2, it looks like. So notice the connection is not quite there, but what we would do if you plugged in 1/2, you'd notice if I plug 1/2 into here, it would make this part equal to 0. And actually that happens on all of them. If you were to plug 0 in for this x, it would make it 0. If you plug negative 5 in for here, it would make that expression equal to 0. So we're pretty much going to be looking at where the expressions are going to equal 0. So hopefully you can see that connection. If you see that connection, feel free to use it as we're factoring. Alright, so to solve a quadratic equation by factoring, you should make sure the equation is set equal to 0. Number one thing. Alright, then we will factor the expression, and then we will set each part equal to 0 and solve for x. This part sometimes we can skip if you see the connection that was made. Okay, your answer will be where the parabola hits the x-axis or where the object hits the ground. That's the whole goal of solving a quadratic equation. All right, so this one, when it says solve each equation below by factoring, again, I'm going to circle the word solve. I know that before I'm done, it has to say x equals. It's going to be very tempting on these problems to factor it and then stop, but you're not done until you tell me what x equals. All right, so this one, you will notice this is a good one for factoring because we do have a trinomial that looks like we could factor it. It is equal to 0, so I am set with that. So when we factor this, put a 1 in front, we're going to get x and x. we'll get negative 30. I'll be thinking, what times what gives me negative 30? Negative 6 times 5, negative 5 times 6. I'm looking for a negative 1 in the middle. Negative 6 plus 5 does it for me, so minus 6 plus 5. All right, so now hopefully if you remembered the connection that we made between the x-intercepts and the factored part, we should get x equals 6 and x equals negative 5. All right, if you're having trouble seeing that connection, you could always just set each part equal to 0. So we could set x minus 6 equal to 0, and we could set x plus 5 equal to 0. And when we do that, we're going to get x equals 6, and we'll get x equals negative 5. All right, okay, next one. We are going to solve this by factoring. The first important thing, it has to equal 0. This one does not equal 0. So to get rid of the 8, we'll subtract 8 from both sides. So my left side will now be 3x squared minus 2x minus 8 is equal to 0. All right, we are now ready to factor it. We're going to have 3x and 3x. Don't forget that we're going to have to divide by 3 before we're done. 3 times negative 8 is negative 24. Let's see here, negative 6 times 4, negative 4 times 6, negative 12 times 2. I'm looking for a negative 2. Negative 6 plus 4 will give me that negative 2. I will divide the first one by the 3, so I will get x minus 2, 3x plus 4. Okay, so now we are ready to figure out our x-intercept. So I'm going to have x equals, on this one we just take the opposite, which is going to be 2. On this one, just like we did in a previous one where I graphed, if there's something in front of the x, you're not going to get something that's a very nice number. So what we're going to do instead is take what's inside. This is actually calling the zero product property. We are going to take what is inside and set it equal to 0. So if we set that equal to 0, we'll subtract 4. We'll get 3x is equal to negative 4. And then if I divide both sides by 3, I'll get x is equal to negative 4/3. So if I were to graph it, those are the two places that I would see it hit the x-axis. Right, problem 3. Once again, this is not set equal to 0, so I need to set it equal to 0. So we will subtract 2x from both sides. So I'm going to get x squared minus 2x is equal to 0. Notice I didn't put those together because they're not like terms. From here, this one is actually going to be a GCF problem, so I notice that they both have an x. So if I divide out an x from both of them, I'll get x minus 2. All right, and now from here, you can either recall from graphing that we got x equals 0 and we got x equals 2, or you could just set each of the parts equal to 0 because of the zero product property. So either way, we'd get x equals 0 and x equals 2. All right, number 4, again, it doesn't say equal 0, so we're going to subtract 7x from both sides. The tricky part on this one is making sure that you write this in standard form. So this should say x squared minus 7x minus 30. The x term has to go in the middle. This now does equal 0. We now can factor it. That's why we've been practicing our factoring, so we're real good at factoring, so that doesn't get in our way. 1 times negative 30 is negative 30. We will then think what times what will give me negative 30. Negative 10 times 3, negative 3 times 10, negative 5 times 6. I'm looking for negative 7. A negative 10 plus 3 will give me negative 7. Oops, so negative 10 plus 3. Okay, our zeros are where it touches the x-axis. The opposite, of course, so we'll get x equals 10 and x equals negative 3. And once again, if you are not seeing that you just take the opposite, you can always just use the zero product property and set each part equal to 0. So you could do x minus 10 equals 0 and x plus 3 equals 0. And when you do that, you will get the exact same answer. Okay, we're going to try a couple more. This one, it does say equal 0 already. I do notice that we can do the GCF because there's an x in both of them and 2 goes into both parts. So we're going to factor out a 2x. So 2x, this will leave me with x minus 4 equals 0. And then from here, once again, if you're not sure what this is going to be, since we didn't really have any ones with the 2 in front of it when we graphed, just set that equal to 0. 2x is equal to 0. If I divide by 2, x equals 0. This one will be x equals 4. It's just the opposite, or just set it equal to 0 and solve it. So those would be my two places. Right, the last one, I personally, although we will do this one by factoring, I think if I solve this one because the x term was missing, I would solve by square roots, but we can factor it, so I just want to show you that. If we factor this, since you can square root 100, this will factor as x plus 10 times x minus 10. And so when we solve this, we'll get x equals negative 10, and we will get x equals 10, or the fancy way that we've been writing that is positive and negative 10. So hopefully now you can solve quadratic equations by factoring.